Hello class, welcome to this video on AP Statistics, Lesson 4.1, Sampling and Surveys. So this chapter is very important in the study of statistics. It is the non-calculation part of the unit. It's very conceptual. It's about experimental design, experiments and observational studies. There's a lot of conceptual stuff here, and a good chunk of the AP exam is devoted to this content. So this chapter is very important. I would say about 20% around there of the AP exam is on this unit alone. So there's a lot to go over and make sure that you understand. So let's take a look first off, the difference between a population and a sample. So population in a statistical study is when you study every single person in the entire group of individuals. So, for example, the U.S. Census study is a census that is a study that studies the entire population of the United States, right? And so that is called a census, all right? So a census collects data from every single individual in the population. And again, I mentioned the U.S. Census. It's something that occurs every decade. So every 10 years, they collect a count of every single person in the nation, in the U.S., and the purpose of that, it's mandated, right? It's a constitutional thing, so it's mandated in order to make sure that you have enough representation, enough seats in Congress and things like that. So very important. So, but most of the time, we're not able to collect data from every single individual in the population, and so what we need to do is take a sample. So a sample is a subset of individuals in the population from which we actually collect the data. So obviously the sample is going to be smaller, and it's more convenient to take a sample than it is to sample every single person. So let's take a look at the population. This is the entire group of individuals that you're studying, and then you're taking a subset of that, right? It's called the sample. And so you're collecting data from a sample. Now, ideally, this sample has to be representative of the population. It can't just be any sample. And the way that you have representative samples is by randomization, okay? So you need to introduce a random sample where every single person in the population has an equal chance of being selected. And if that's the case, then you have a random sample, and there is a good chance that a random sample will be a representative sample. All right, and you want it to be representative because, again, you're trying to take a shortcut. Instead of studying the entire population, you're using a sample. And so once you study the sample, you're able to draw a conclusion about the population from that sample. And that conclusion is known as an inference. All right, so you're making an inference about the population. This is essentially the study of statistics right here in a nutshell. This picture right here. Essentially what we're trying to do is we're trying to study populations by taking samples and setting up an experiment in such a way, or observational study, to be able to draw conclusions. All right, so here's an example. Identify the population and sample in the following settings. Part A, the quality control manager at a factory that produces computer monitors selects 10 monitors from the production line each hour. The manager inspects each monitor for defects in construction and performance. So let's take a look at that one first. So for part A, the population, in this case, you're studying every single thing. In this case, what is every single thing? Well, it says here that you're selecting 10 monitors from the production line each hour, right? And so the population that you're selecting from is all the monitors that were produced in that hour. This is important right here. So I want to make sure that you understand that you're talking about the monitors each hour. And so however many monitors they produce in that hour, let's say it's 100 monitors, that's your population, okay? So you want to be specific when you're identifying your population. So in this case, the number of monitors produced, all the monitors produced in that hour. The sample is the 10 monitors that you chose. Now part B, the population here, you're saying a news organization surveys 1,000 voters to predict which candidate will be elected as president. So the population is all registered voters. The sample is the 1,000 that you selected. Okay, so it's pretty straightforward to identify population versus sample, except you got to be specific. So in the first example, you want to be specific and say, well, in part B, you want to be specific and say it's all registered voters. It can't just be anybody. Part A is all the monitors produced in that hour. So that's key. All right, so sample surveys. The idea is that we want to draw conclusions about an entire population by taking a sample. So so choosing a sample involves some planning. And there are ways that you can choose samples, and we'll show you how to do that. We'll show you how to not take samples, and then we'll show you how to take samples. All right, so a sample survey is a study that collects data from a sample chosen to represent a specific population. So let's show you how to plan a sample survey. So first, you want to decide the population that you want to describe. So who are you studying? Then you're going to decide what you want to measure. So like, what characteristic are you trying to study? Are you trying to study the height? Are you trying to study the aged population? Are you trying to study the average BMI, the average cholesterol level, whatever you want to study? And then decide how to choose a sample from the population. All right, and there's ways to do it well, and there's ways to choose samples poorly. We'll talk about that. So let's talk about how to choose samples poorly, bad sample methods. So when we sample, we want to avoid something called bias. All right, so bias is essentially where you're consistently off target. Okay, so you're off target. So let's say the average height of the population is, I don't know, 5'8" inches, but then you take a sample. And you take a sample in such a way that you have bias. So like, for example, maybe you sample all of the basketball players in different states. Well, that is a bad sample because now you're introducing bias, right? So if you're sampling basketball players, that's going to introduce a very high height, right? So if you take that sample basketball players and measure their height, the average height is going to be way greater than, let's say, might be 6 foot. Compared to 5'8" inches, if you were to compare the averages. And that's what we refer to as bias, right? So you're off target for a specific reason. So here, if you consistently overestimate or underestimate from your study, then that's referred to as bias, all right? So in the case of the NBA or the basketball, we were consistently overestimating. We were overestimating because we estimated it to be about 6 feet when the actual amount was about 5'8", right? So we consistently overestimated in that example. All right, so now let's show you a bad sampling method. So one way that you can sample poorly is by choosing individuals who are easy to reach. This is referred to as convenience, right? Because they're conveniently located near you, then that's why you would survey them. That's called convenience sampling, and it's very poor. So, for example, you might see, maybe you're in a mall and you see a bunch of people. You survey the person that is like next to you or like right near you, right? So then the people that are far away from you are less likely to be chosen than the people who are near you, right? So that's a convenience sample, and that's not a very good way to represent your population that you're trying to study well. So here's another example, sampling the first 10 people that walk into a classroom. So that's convenience, right? The first 10 people that show up, those are the people that you survey. Now, the reason why this introduces bias is because the first 10 people walking into a classroom might have a certain characteristic in common. The first 10 people might be if you're talking about students, right? They might be the high-flying students that just like to get there early, and therefore sampling them might affect your results, right? That's just an example. Convenience sampling often produces data that is not representative of the population and will almost always result in bias. So another way is called voluntary response sampling. So it allows people to be chosen to choose to be in the study. So in other words, people are self-selected to participate in the study. They select themselves whether they want to be in the study or not, right? So you provide a general invitation and then people choose to be in the study. And that introduces bias as well. Easy example is a call-in radio show. A radio show says, okay, call in this number, and then, the first people to call in or whatever, or take an internet poll. Like, so this involves a volunteer to respond. Now, people who self-select to participate usually are not representative of the population of interest, right? Most people are not self-selecting to participate in these things. And those who do self-select have a certain characteristic that makes them not representative of the population as a whole. All right, so here's an example. In 2016, Britain's Natural Environment Research Council invited the public to name its new $300 million polar research ship. To vote on the name, people simply needed to visit a website and record their choice. Ignoring names suggested by the council, over 124,000 people voted for Boaty McBoatface, which ended up having more than 3 times as many votes as the second place finisher. What type of sampling did the council use in their poll? And explain how bias in the sampling method could have affected the poll results. Well, first off, it says that the people needed to visit a website and record their choice. So people are volunteering, right? So this is a sample where you have volunteers. People self-select to include that. Now, the bias here is that people that self-select to visit the website and record their choice, these are the people that would likely vote for the silly name, right? And therefore are not representative of people as a whole. So what we can say is that they use voluntary response sampling. People chose to go online. People who chose to respond were probably the ones that wanted the silly name, right? The Boaty McBoatface. So they're probably less serious about science than the British population overall. And so they're not representative of the population. Okay. Hopefully that makes sense. So because of this, what we're going to expect is that the proportion or the percentage of people who prefer the name is likely to be greater than the percentage of all people, all British residents who would choose the name. So most British residents would not choose the name, but it looks, and so that would be less than the percentage that actually chose the name who self-selected. So hopefully that makes sense. So therefore we have the bias. So we actually, in this case, overestimated the number of people who would actually vote for that. All right, so here are some examples of good sampling methods. So what we want to do in order to have a good sampling method is to introduce chance, right? So introduce an element of randomness. So a sample chosen by chance rules out favoritism or self-interest by the sampler, all right, as well as self-selection by the respondents. So we want to eliminate that stuff. We want to eliminate favoritism. We want to eliminate bias. We want to make it done just by chance. And so we need methods that would help us reduce bias by being random. And so one way is obviously doing a random sample. So you use a chance process to determine which members are included in the sample. So you could use a random number generator. You can do a raffle where you put in names on a hat and then you select the names, right? And then that's just random as long as you mix the names in the hat. You can't just have the names thrown in the hat and then you select it, right? That wouldn't be random. You'd have to actually mix the hat and mix the results, right, before you select one. Names. It's a way to make it random. So a simple random sample, or SRS, is chosen in such a way that every group of individuals chosen has the same probability of being selected, so the same chance, okay? So having the same chance of being selected enables us to not have favoritism or bias in our study. So example, selecting using a random number generator with technology, or selecting your sample using a raffle, etc. This is what we talked about earlier. So how to choose an SRS with technology. So this is with the random number generator. So first thing you want to do is a label. So give each person a number, right? So if you have 50 people, give them a number from 1 to 50, or 1 to 49, or 1 to 50, right? So you give each person a number, and then you want to randomize it. Use a random number generator to select X amount of numbers. So let's say you have 50 people. Their numbers are 1 through 50. You want to select 10 random people. So you're going to use the calculator or computer or whatever to randomly select 10 different numbers, right? From 1 to 50, right? Where n is the sample size. So then you choose those individuals that correspond to the randomly selected numbers. We'll look at an example of this so you can see how it works. If you want to use a table, there's an actual table that enables you to randomly choose people for your study. And this is table D. This is the table that's in your book. And it's called a random table of digits, right? And so what you do is you give each member of the population a distinct label with the same number of digits. Use as few digits as possible. So in this example, 01, if you had 50 people, it'd be 01 to 50, you're right? 1 to 50, 01. 01 because there's 2 digits that you're looking at. And then randomize. So read consecutive groups of digits of the appropriate length from left to right. So in the table, you read it from left to right. You ignore any numbers that weren't that isn't 1 to 50 basically, or that is a copy. So if you chose 20 and then you see 20 again on the table, you ignore the second 20. All right, and then choose those people. So again, we'll show you how this works when we look at an example. So here's an example. We're going to use table D to choose a simple random sample of 4 hotels. Sorry about that. So first off, we have this line right here is from the table. Okay, so let me show you this line right here that you see of digits is from table D. So we choose a row from table D. Here, this date, we use line 130 in order to choose our random sample. Okay, so we want to choose 4 hotels. So we're going from, and remember we have from 01 to 28, right? So we have 28 hotels to choose from. So we're choosing from 01 to 28. Whichever one we see first, that's the one we choose, right? From left to right. Okay, so first off, we see a 69. So what we're going to do is we're going to take this line and we're breaking it into 2 digits, right? Because these are all just 2-digit lines or numbers. And then we're going to say, okay, well, 69. We can ignore 69 because that's not from 1 to 28, right? The next one is going to be 05. That is a number, so that's going to be Beach Castle, right? So Beach Castle we can choose as our part of our sample. Now 16, we can choose 16. So that's Radisson here. So we can choose that. And then that's 2 so far. We need 2 more hotels. Now 48, you can't choose 48 because it's not part of our number of hotels. 17, you can choose 17. That's Ramada here. So that's 3. We need 1 more. 87 is not part of our number of hotels. 17 is a duplicate, so we cannot choose that one again. If we can't choose 40 or 95, they're outside. 17 is another duplicate. The rest of these are not part of our study or sample population, and so the last one has to be 20. So that's a total of 4 hotels. Now, if you run out of numbers on this line, you can move to the next line on the table, right? But here I just showed you 1 line of numbers. So our simple random sample of 4 hotels is given 05, 16, 17, and 20. So pretty simple to use a table D for that. So let's use this technology. So do the same thing and use technology to select our sample. Obviously, because we're doing this randomly, we're not going to have the same number of hotels, right? We're going to have a different sample of hotels. So first, you want to go to math, then go to probability, PRB. Then you want to go to random integer, number 5. And then you want from 1 to 28. So 1, 28. Close parentheses. Now it's going to give you 20. So that's our first number is 20. We can repeat the process. And so now we're going to do 25. We don't select the second 20. So we got 20, 25, 11, and 4. Okay. So those are our 4 different numbers, right? 4 unique numbers. Okay. All right, so again, we're just kind of showing you another way to do this is if you do 1, 28, comma, and then you put 4. What that does is it gives you 4 random numbers. So you can use the random 28 function or random integer 1, 28, that function, or you can put comma the number of numbers that you want. Okay, obviously these have to be different. So if you have 2 20s, you're going to have to generate it again in order to get a different number. Okay, because sometimes they randomly generate a number and it's the same number. All right, but in this case, we're going to use the ones that we had here earlier, the 4, 11, and then the other 2. And in that case, we chose 20, 25, 11, and 4. Those were our 4 numbers from the calculator. okay? Again, we're not using these numbers, we're using the ones that we had before. All right. Okay, so that's how you use technology or the random table. So now, how to choose an SRS. When describing how to choose a simple random sample on the free response section, make sure to include these three things, okay? So think of this as a template. So label all blank from blank to blank. So for example, label all hotels from 1 to 28 in alphabetical order. Okay, so that would be how you would write, the first part. Then you have to talk about how you're going to randomize it. So then if you're using the table D, then you say, okay, move along a random line of random digits from left to right, reading, in this case, 2-digit numbers for our example before, until 4 different numbers from 1 to 28 have been selected. Ignoring, so in this case you would say 01 to 28. You have to do 01 because 01 is the number 1 on the random table, okay? Have been selected. Ignoring repeated numbers and the numbers 0, like, so you want to ignore, for example, 0, right? Because like 00, right? Or like, any number like 50, right? Any numbers like 29 and on, right? 29 to 100 or something like that. You want to ignore those. And then select, audit the 3, in this case, hotels or whatever, blank hotels that correspond with the number selected. Let me cross this out. Audit the blank. So that it doesn't have to be 3. It could be 4. In our case, it was 4. So this should be a blank. So you can ignore that. Audit the blank that correspond to the number selected. So in this case, the 4 hotels. So this is a good template for the free response. All right, so let's look at an example, and we'll use that template to help us. So each year, the State Department of Education randomly selects 3 schools from each district and conducts a detailed audit of their attendance records. So, all right, so we want to randomly select 3 schools from this district of schools, so right here, from this list. How do you choose a random? So describe how to use a table to choose a random sample of 3 schools from this list. All right, and then we'll do this with the random digits. So let's talk about A. So how to use a table of random integers to select an SRS of 3 schools. So label the schools from 01 to 19. Again, 01 because we want to use 2-digit numbers. Move along a line of random digits from left to right, reading 2-digit numbers, right, until 3 different numbers from 01 to 19 have been selected. Ignore repeated numbers and the numbers 20 to 99. So again, we're ignoring 20 to 99 because those are our 2-digit numbers that we want to ignore. We don't care about those. And we want to also ignore 00. Audit the 3 schools that correspond with the number selected. Okay, so there's your template. All right, so let's use the random digits here to choose our sample. So again, the 2-digit numbers, we're going to break this list that they gave us into 2-digit numbers, right? 62, 08, 16, right? So 62, 08, 16, which is 16 here, so on and so forth. And then we're going from left to right, choosing the ones that we can. So 62, we can, so we're going to skip 62 because that's not from 01 to 19. We're going to select 08 and 16, so this is pretty good. Select those. Skip 48. 16 is a repeat, so ignore that. That's a repeat. Skip 87, 37, 40, 95, and then we are going to select 17. And we can stop there because we got 3 schools. So the 3 schools that we selected are 08, Harrelson Elementary, 16, Prince Elementary, and 17, Rio Vista Elementary School. Okay, and that's how you do it. All right, so let's talk about other sampling methods. So one common alternative to simple random sample is called stratified random sampling. Stratified. So stratified is called stratified because you're breaking the population into groups called strata, Okay, the singular form of strata is a stratum. Okay, so a stratum is a single group. Strata is multiple groups. Okay, so you're breaking a population into strata. That's a group of individuals who share some kind of characteristic that is associated with the variables being measured. Okay, so for example, we'll provide an example of this, but you might want to break groups by, for example, gender or something like that, right? They share a characteristic that you think, a common characteristic, right? So stratified random sampling selects a sample by choosing a simple random sample from each stratum. So you break the population into strata groups, and then you do a simple random sample of each of the stratum, or each stratum, and then you combine it to get your result. All right, so this method works best when individuals within each stratum are similar, homogeneous with respect to what is being measured, and there are large differences between the strata. When done well, this method can give more precise estimates than simple random samples of the same size. So if you were to choose between simple random sample and stratified, you would choose stratified as it gives a more precise estimate, as long as, like we said, the stratum are similar, right? You're breaking down the groups into ones that are similar. But then each group is different from each other, right? So here's an example. High school students, a population being split into the following categories: freshmen, sophomore, junior, and seniors, right? Each of those groups are homogeneous, meaning all freshmen are in one group. All sophomores are in a separate group, right? Each group by itself is just freshmen or just sophomores. And then taking simple random samples of each stratum. So you select a certain amount of people from each freshman group, from the sophomore group, from the junior group, and the senior group. And then you combine those people, that will be your sample. Let's say we took 5 random freshmen, 5 random sophomores, 5 random juniors, 5 random seniors, and in total we have 20 people in our study, okay? So now, when you take this, you can say 5 of each group, or you can, let's say you have way more freshmen than you have seniors. Then you could make it so you select more freshmen than seniors. That's called taking a simple random sample based off of proportionality. So for example, let's look over here, right here where it says it can be proportional to the size. So if freshmen are way bigger, you can choose more freshmen, or you can just make it the same for each one. Okay. All right, so now another sampling method is when you have people spread out over an area, you can actually select them based off of where they are, right, location. That's known as cluster sampling. So a cluster is a group of people that are located near each other. And so cluster sampling selects a sample randomly. So you randomly choose clusters. So basically you group people based off of where they're located, those that are near each other, and you group them. For example, counties, right? People that are located in Lake County, you can group that into a cluster. People that are in Pinellas County, you can put that as a cluster, right? You have all these different counties or locations, right? Or cities or whatever. And then you randomly pick a few counties, right? So let's say I randomly pick Hillsborough County, and I randomly pick Orange County or something like that. And then I select every single person from those 2 counties, okay? That's called a cluster sample, right? I randomly select clusters, and then I choose every single person in that cluster. So again, this method works best when people in the clusters are heterogeneous, like the population. What that means is that you want diversity in the clusters. So if I break people up into Pinellas County, right, that's a cluster, well then the people in Pinellas County have to be representative of the population, right? They can't just be all retired people or whatever. You know what I'm saying? It can't be all the same group of people. They have to, this works best when each county or cluster in this case is heterogeneous. The sampling method is often used for practical reasons because obviously people are in that area, so it's easier to just survey them, save time and money. So again, taking the population of a country, dividing it into many regions, then take, for example, counties or states or whatever, then using a simple random sample of 3 clusters, and then from these 3 clusters, every single individual is included in the sample. Again, a cluster should be representative of the population. However, most of the time, this is not the case, right? So we have to take into account the fact that if we do a cluster sampling, we may have a little bit of bias in the study. Okay. However, it's still random, and so it's still one of the better methods than if you made it completely non-random, right? Another way to choose a randomly sampled sample randomly is by systematic methods. So systematic is when, for example, I want to select every third individual that comes in. So every third student that comes in, I will sample them. Okay, so that's called systematic. So you have an ordered arrangement of the population. You randomly select one or the kth person that comes in, one of the first k individuals, and then every kth person after that. Okay, it's useful in certain situations. So for example, on election day, you may not know how many people are going to show up that day. And so you may choose the fifth person that shows up, right? Every fifth person after that. And then that will be your sample. Okay, and that will be random in a sense because you don't know who's gonna be the person that shows up, right? So if there are patterns in the population that coincide with the pattern in a systematic sample, then it may not be a good representation. So if you see that, certain people, you see a certain pattern in the population and that's mirrored in the systematic sample. So let's say you know that by doing a systematic sample, you know that every X amount of person is going to be this type of person, right? Or, you have a certain pattern and you know that pattern, then obviously it's not going to be good. But obviously if it's random and you don't know who the fifth person is going to be, right? You have no knowledge of that. You have no idea. Then it should be fine for most purposes. Okay, so here's an example. So the student council wants to conduct a survey about the use of the school library during the first 5 minutes of an all-school assembly in the auditorium. There are 800 students present at the assembly. Here is a map of the auditorium. Note that students are selected by grade level or seated by grade level, and that the seats are numbered from 1 to 800. So you can see that from the key here. It says that 9th grade are seated in seats 601 to 800. 11th grade, seniors are 1 to 200. So the seniors are in the front rows basically, and then the freshmen are in the back rows. Okay, essentially that's what it is. So describe how to obtain a sample of 80 students using a stratified random sampling. Explain your choice of strata and why this method might be preferred to simple random sampling. Okay, so remember, stratified random sampling is you break them into strata, which means in this case, freshman, sophomore, junior, and senior. Those are my strata, right? So that's perfect for this. And then you randomly select from each stratum. So you randomly select X amount of people, okay? In this case, if you want to get 80 students, then you might select 20 from 9th grade, 20 from 10th grade, 20 from 11th grade, and 20 from 12th grade, right? So that's an example. And then we're going to explain how we do this, right? We want to do it randomly, okay, of course. For the first part, because the student's library use might be similar within grade levels, but different across grade levels, we can use grade level as strata. So we're just talking about, okay, so grade level is a good choice for strata because it actually has differences in their library use. We would expect that maybe 9th grade has a different library use than 12th grade, right? So that makes sense. So grade level as strata is pretty good. And then we're going to show you how to do that. So for 9th graders, generate 20 different random integers. You got to include the word different. Different is key here, okay? This is the difference in a free response question, getting a point or losing it, right? So generate 20 different random integers from blank to blank, in this case 601 to 800, and give the survey to students in those areas, all right? And then you give those surveys, so that's 20 people. Do the same thing for sophomores, juniors, and seniors using their seat numbers, right? So in this case, juniors from 201 to 400, and so on and so forth. All right, and that would constitute a stratified random sample. Now for part B, describe how to obtain a sample of 80 students using a cluster sampling. Explain your choice of clusters and why this method might be preferred to simple random sampling. All right, so Remember, cluster is when you group people based on location. So those that are near each other, those are the ones that you're going to select, right? Now, it's not good in this case to select a cluster sample based on the row. Why not? Like based on, for example, the first row. And you might want to ask yourself that question. Why wouldn't it be good to choose a cluster that is, for example, rows or a row? Well, the reason why you wouldn't choose a row or rows is because the rows are homogeneous, right? They're the same group of people. So in this case, from 1 to 20, those are freshmen. So if I choose people from this row, it's only going to be freshmen, and therefore it's not going to be representative of the population. So hopefully that made sense. So you want to choose the clusters so that they're representative, they're heterogeneous. There's different groups of people. In this case, 9th grade, 10th grade, 11th grade, and 12th grade, right? So we do not want to choose rows. So the better idea would be to choose columns, right? So if I choose a column, that ensures that I got 9th graders, 10th graders, 11th graders, 12th graders, right? So that's something to keep in mind. All right, so let's go to our response. So each column of seats from the front to the back, from the stage, this should say stage, by the way, from the stage to the back could be used as a cluster because it will be easy to hand out surveys. So that's fine. You can hand out surveys here, right, to each person there. It'll be easy to hand out the surveys to an entire column, and you're going to have a heterogeneous sample, all right? So label the columns from 1 to 20, starting at the left side. So remember, we have 800 all the way from 1 to 800, and so in this case, you're going to have, the columns. So label the columns from 1 to 20. There's 20 columns. Generate 2 different integers from 1 to 20, and give the survey to the 80 students sitting in these 8 columns. Or I'm sorry, 2 columns. I don't know if so 2 columns. So there's 20 columns, right, from 1 all the way to 20, the 20th column. And then each column has 40 people, right? How do I know that? Well, because if you count it, right? So there's 20 times 40, that's 800, right? So there has to be 40 different students in that row, right? 40 students, or in that column, sorry. So that means we need to choose 2 columns, okay? So generate 2 different columns, different integers from 1 to 20, and give the survey to the 80 students sitting in these 2 columns, okay? So there's 40 students in each column, 40 plus 40 is 80. So that's what you need, all right? And that's a cluster sample. Cluster sampling is much more efficient than finding 80 seats scattered randomly about the auditorium. And remember, that's a simple random sample requires 80 random people. So you could randomly generate from 1 to 800 and then choose 80 people. That would be a simple random sample, right? But it's much more efficient to do a cluster sampling in this case, right? So that's why it would be preferred in this example. All right, so types of bias. Bad sampling methods often lead to what we refer to as bias. Again, we can avoid these methods by using randomness in our studies, so random sampling. There are other problems in conducting sample surveys that we'll talk about. So these are other types of bias, if you will. First type of bias is called undercoverage bias. Undercoverage occurs when some members are less likely to be chosen or cannot be chosen in a sample. Okay, so here's an example of this. Sample survey, if you're doing a sample survey of households, and you're just doing people that are in households, well, you're gonna have undercoverage bias because you're going to not be able to choose homeless people that don't have a home, prison inmates that don't have a home, or students in dormitories that don't have a home. You're only doing sample survey of households, and so you're missing out on those people, and that's called undercoverage bias. Non-response bias occurs when an individual chosen cannot be contacted or they refuse to participate. And you probably can think about a lot, some reasons or some examples would be like if you are trying to call somebody and they don't answer, right? You're trying to do a call random people and have them participate in a study, right? Can you answer a questionnaire for me? Well, most likely that person's going to hang up, or maybe they won't have a phone number that, they won't have the correct phone number in file or whatever. Okay, so landline telephone survey, asking people how many hours of TV they watch. Well, they're going to miss out on those people that can't be contacted or they refuse to participate. Some people don't have landlines, telephones as well, right? So if you're doing a survey with landlines, some people that don't have landlines are not going to be able to participate. Now, the people that do have landlines and the people that do answer may actually be will introduce bias, right? Because people that are watching TV tend to be at home. And if they're at home, they're most likely to respond, right? But people that are working long hours or whatever may not be able to answer the phone, or they just might not refuse to answer the phone. Okay, so in any case, even if people answered the phone or they can't be contacted because they're working, that's going to affect our survey of the number of hours of TV. So either way, it's going to introduce bias. Response bias occurs when there's responses. You get responses to the survey. However, the responses are inaccurate, okay, for whatever reason. There's different ways that you can have inaccurate responses. Maybe the survey question isn't worded correctly, or it's worded in a complex manner, or it's worded in a biased manner. Whatever the case may be, a response bias is when you have an inaccurate answer to survey questions. So here's an example. Survey asked some if they supported stronger gun laws versus stronger gun control laws. See the wording there, gun control versus gun laws. There was a change in the response when they added the word control. Okay, some people don't like the word control when you're talking about that, and so that might influence the response. All right, so here's an example. So what % of Americans wash their hands after using the bathroom? It depends on how you collected the data. In a telephone survey of 1,006 U.S. adults, 96% said they always wash their hands after using a public restroom. In an observational study of 6,028 adults in public restrooms told a different story. Only 85% of those observed washed their hands after using the restroom. Explain why the results of the two studies are so different. And it's pretty easy to tell. There's a bias here because people are going to tend to say that they do wash their hands regularly, but they may not actually do that, right? When asked, they will say that. So when asked in person, many people may lie about always washing their hands because they don't always want to appear to have bad hygiene, right? So there's that bias there. When people are only observed and not asked directly, then you can actually observe the true proportion of those who wash their hands, right? And then we would expect that would be smaller and closer to the actual true value. All right, so that is it for the lesson, guys. I hope you found this lesson useful and informative. As usual, I'll see you in the next one.